So, continuing with the second class today, today we are going to cover topics on testing, and please feel free to stop me. I've muted you both at this point. In case you have any questions, just through the chat window on the GoToMeeting uh, application, just type your question. I'll unmute you, and if we can have to discuss, we'll discuss the question, and I'll try to answer as much as possible. And if I'm going too fast, or just let me know if you don't understand a particular concept. So today we are planning to cover topics related to only software quality. So Madhavi, to get you up to speed, yesterday what I covered some of the topics on SDLC model. I'll just go through the content once, and Hiral, if you have any questions, just ask me in the first day's class. So Madhavi, yesterday we covered a content about what is a system and application, and we talked about like what is an SDLC model, different phases within SDLC model, and within each phase what is the role of tester, what is the role of business analyst and system analyst developers. So we walked through all the roles and the responsibilities for within each phase. So as a tester, where should you get involved, and what kind of documents you will see, and how do you use it to develop test plan was discussed. So I'll just go through from a higher level. I don't want to go through deep through all the slides here, Madhavi. We have a lot to cover today. So I just want to see if we have anything important that I can address. So yesterday we went through a case study, and I have shared the documents to you as well, business requirements, case study, and functional requirements related content. Yeah, and you can see the document, and listen to the video to understand how the document has been prepared and how we can generate scenarios based on the requirements and use cases or business rules. And we also use decision making diagrams, sequence diagrams, and any use case diagrams to develop our test cases. So I took an example of this one to explain on how to create test cases based on the flow itself. If you don't have any documentation, all you have is just the flow diagrams. You still need to use it to develop test cases. So these are the wireframes you might get just before you are able to start execution, and this is one example of a wireframe, or they also call it as layouts. And why we need to test is this is the picture which I've explained yesterday to tell you like what the customer really want is something like this, and but he explained something like this, but we develop something like this. So that's the main reason we have to test each and every component at every stage and within an application. So that was yesterday's class. Going back to today's class, Hiral, do you have any questions from yesterday's class before we start with the day 2? Okay, so if you don't have any questions, I'll proceed with today's class. Today we'll cover topics as how quality is defined. So what is quality, and why do we really need to test a software? Yeah, Hiral. So let me unmute you. Yeah, Hiral, what is your question?
My question is, for the day 1 class, there is like, I have a question about what is an application. What is application? And
from yesterday's class. So application, yeah. Okay, let me go back to the slide from yesterday's.
See, second line, it says what is application, and I couldn't understand that flow chart.
Okay, so let's go back to the picture here. The reason why I want to do this here is, as this is a simple example of how the systems interact within an organization, a complex organization, big size one. So there are different levels of CMM levels called complex maturity, capability maturity model. So if a company is a maturity model 5, they will have different systems interacting. Like you have a front-end system, you have a back-end database, but there are many components in between. So in here, we have different types of systems like transaction processing system. So it's also
Okay.
called as application. If you develop a web application to interact with the transaction processing system, it is pretty much, they are interrelated. They are not two separate individual pieces, but they both go together. So you develop either a database application or you develop a GUI application. You call this a GUI application, but there might be, a system where it can have one or more applications together, or it can just be the application itself. So you use library, you check out books from library. It's a library information system. So they don't have too complex application there. All they have is a front end, a web content there where you enter your information, and that information is stored in a web server, and that becomes a system. But there are two different applications interacting there. One is a front end application, other is a database application. Okay.
Okay, back front.
Yeah. So if there might be a possibility that there can be only one application. For example, I'll show you. So this is an application which Mercury used to provide long time back. Let me see if I think it's still the same username and password. Well, it works. Great. So this is application, a sample application provided by Mercury. Was the owner of Quality Center in the past. Now HP owns it. Now in this application, this is for travel agents who, let me mute you, Hiral.
Okay.
So this is a travel agent application where you enter details of your flight and all the information. And now this is only one side of application. Where the data is being transferred, it might either interact with another application, or the data can be stored in a spreadsheet, or it can be a simple access database. We don't know. So they can be like one or two applications. And this one is a very simple one. Still, for this application to perform, it has to interact with some other application. So if you want to get the flight reservations, this particular application has to interact with the database, pull all the flight information that is available on a particular day. So it's always one or more applications together. I hope I have explained you. Stop me if you still didn't understand it. So going back to today's topics, we will cover what is a QA process and when should testing start, and also what is the defect, scope of testing, basic testing vocabulary that we might possibly use in our regular day-to-day job when you start working as a QA analyst. And there are three different terminologies that within quality assurance, we always say QA, but there is quality control, and it's different from testing as well. So what are the differences between all these terms and where they really come into picture? And we'll talk about life cycle testing, independent testing, what they mean, and different levels of testing that we need to do over a particular project or a program. And how do you determine the cost of quality? What you need to, we talk about quality many times, but how do you calculate the cost? Like, how do you measure it? If you invest on something, if you don't get the returns back, it doesn't make sense. So you have to make a right cost. So we'll cover all the content, and also we will see software testing as a big picture in a real-time environment. I'm going to take some examples and documents that I might use. I think there are only a couple of documents for today's class, which I have planned to use. So we'll be using a traceability document today and a process management document. Okay, let's begin with the class now. So how is quality defined? If I have put some simple statements here. You can come up with different meanings. If you search on internet, you will have so much content, it will definitely confuse you. And if you put it simply, it's just nothing but a degree of confirmation on to explicit or implicit requirements and expectations. Explicit are something, we specifically tell that these requirements need to happen for a particular application or system. So I will use application for now, because system can, as I told you, it's a complex environment. It can have multiple applications. So if we take one application, and the quality of application has to be tested, I mean, make sure that is maintained. So in order to do that, we test it. So the quality is nothing but it's a degree. We are assuring our partners that we are testing this application and making sure it is uh, valid with all the business rules and requirements that you have provided for this application. If these expectations are not met, then we will let them know that application has to be either rebuilt or reworked or fixed wherever there are issues. What is an explicit requirement? It is clearly defined and documented. So either in certain scenarios, you will have enough documentation that you can create your test cases. So test cases, again, it's nothing but to make sure the quality is maintained. So in order to do that, you need to have proper requirements. If you don't have clearly defined requirements, which are like dual, or which are confusing, or which can add multiple meanings to it, then it will be difficult. So the ones which are clearly defined, like yesterday's document, we have looked at some of the requirements. For example, I'll go back to yesterday's documentation. So this is a document we reviewed yesterday about a virtual art viewer. Okay, if the customer doesn't have enough information on what exactly he wants, then it's very complicated. It's difficult to create the application itself. So in this particular document, yesterday we have seen he has created certain documents on what his expectations are for this product, and he outsourced this project to a IT company to build it. So these are explicit defined requirements which have numbers, which have certain content, a layer, and all the information. Like for administrator area, what should be the requirement, how we need to test it. If you are in a user area, what should be the requirement and what should be displayed. So these are explicit. In some cases, what happens is they will just give you flowcharts and use case diagrams, and they will ask you to create the test cases. So in those situations, you still need to be ready to create your test cases. So those requirements are called implicit requirements. They are not clearly defined. All we know is the flow. We know a particular website or portal works in a certain fashion, and we don't know. We only know from the business standpoint like what happens, but we don't know in detail flows. So those are called implicit. Okay, and requirements can be business requirements, can be product requirements, can be a software application requirements. The requirements can be defined, classified into like multiple different layers. You can have security requirements, you can have installation requirements, can be different combinations. So what is the final expectation? We are making sure our end user is satisfied with the product. So you are working in a company, for example, you join a company, a big CMM level 5 company, and you have multiple teams in it. You work on a particular product. You are designing it. You, as a QA, your role is to test the product and make sure it meets all the requirements and they are satisfied. So who are your end user customers? There might be another team within your same company who might be using the same application to the data coming from the same application to some other application. So indirectly, your end users are within the company. They are not even outside. They are within the company who might be using it. So in some situations, you develop an iPhone app or you develop a website. Okay, your end users can be somebody else outside. So when they start using your portal, they start entering information and they might see bugs there. So if you think in terms of the user, like what he is expecting based on the requirements, you have to come up with the test cases and scenarios. And the scenarios should have explicit, even irrespective of how the data or the content available. Make it as simple as possible. When we create high-level scenarios, when we create test case, I'll tell you how to go and make it, break down. I always do this. However complex the application may be, I break down into multiple layers. When I break down, everything becomes easy. Then I'll go so much sub levels. Then I'll come up with a particular flow to make sure the business flow is checked thoroughly. And once all these expectations are met and the data is sufficient for any other downstream application. So when I say downstream application, the data from your application is going to another application. So I want to take a best example actually. For example, I commonly use hotels.com as the portal, and in this portal we are searching a hotel, we are booking a hotel online, and when we make a payment, it might not be on hotels.com, it might be going to somewhere else, it might be some other site. Without knowing, we are passing all the data under layer through either web sockets or through web service layer. The data is transferred from your application to other application without you knowing it, and you make the payment. So that application is your consuming application. So making sure you pass all the information. What if you don't send certain content, you don't send the amount, or you don't send your name or any actual hotel name that you're planning to book? If I select this particular hotel and I try to book it, and you don't transfer the information about this particular hotel to another hotel, what's going to happen? That application won't receive the data, and the layer in between, it's going to fail. So our testing is to make sure when we test application testing, we test only one application, but when we do integration testing, we test both the applications together. So we'll go in detail when we talk about different applications and how they're interacting. But now, to understand the definition, you are assuring your end users the quality of your application. Now, is quality a single dimension? I can clearly say it's not a single dimension. So what are the different parameters that vary within the quality? A quality of a product, it can be based on its progress. So such as use case demonstrated or milestones completed. You can check before even the application has been created. Let's say if Facebook was developed right some time back. So Facebook, when they started working, the guy he started on his own. He had some charts, he has some flow of the content, what he wanted to develop, but he didn't write any documentation. All he had was pictures. He wanted to see this content where a user has to be created. Then he should have friends. He should be able to send messages. That's all he created. But he created using all the pictorial graph. If you see the movie about Facebook, that's all he did. So you were, as a tester, before even you test, how do you measure the quality before even it started, it has come to your stage? So you look at the requirements document, or you look at the use cases, and if there is a gap in the use cases, or the data, the flow is not connected, you're identifying a defect or a bug at very early stage. The cost of fixing the bug at that stage is very cheap. All you need to do is, if you are very good and you understand the entire business logic, you identify it then and there, and you raise a bug against the analyst or the architect. But it's a very rare scenario. You have to be really too good to even catch something like that. Architects are very smart guys. So as a tester, you have to have worked on that particular application for a long time. If it's a new one, it's very challenging. So by the progress of the use case, you can make sure that the quality is going in the right direction or not, whether we are creating the right documentation. And variance. Now the project manager will come up with the project plan with all the tasks, milestones, and deliverables at every stage. So first requirements will come, then design will be created, design documents, then development will start. At the same time, we'll start with test planning. So everything has to occur in sequential order if it's in a waterfall model. So if none of them is occurring properly or the plan is not correct, like if coding occurs before even the design is complete, then that's not correct. You can clearly make out that something is really wrong there. So those are the another type of quality that you can easily identify without testing anything. Reliability, a resistance to failure. Like if you know an application, a database, which might not work in a particular environment, and you can easily tell it. I mean, if I take a best example, if two different databases, they don't, or two applications, like if you have application on Java, you have application on .NET. Okay, I'm taking an example here, a web based applications, and these two applications might have been generated using a certain different technologies. Now you want to transfer data from one application to another application, and there might be a challenge on how to transfer the data. If both are on the same technology, it will be much easier, but somehow this happened. We had a legacy system where the application was developed very old with some other Microsoft tools. Now we moved into Java. Now you want to transfer the data. You don't want to switch off the old application, but you still want to use the data from there. Then from by experience, that this might not work. Then this is something that you need to raise, escalate. Okay. And the function, the artifact implements and executes the requirement use case as intended. So what the function of a particular project, like based on all the documents, whether they're implemented in the right fashion, whether we have they are created such a way that any new person who starts writing a test artifact, he should understand the entire flow, performance, and also we we schedule it. But in this case, I talked about the artifacts executes and responds in timely manner, but it's about documents. But in some cases, you can any application which performance is not good and might not work. Then these are the things that you can come upfront and let the team know that this might not work. Okay, so there are many parameters to quality. I mean, these are like the ones which you commonly see in a day-to-day job. Now, why do we really need to test software? Testing plays a very important role in achieving and assessing the quality of a software product. Okay, I've written these sentences based on my knowledge and experience so far. I've worked in like 6 to 7 companies so far, and most of them are very big ones. So without testing, I haven't seen any company succeed or any program or project being successful. So there are some agile projects where developers create the application without testing, or they do some testing and roll the product into production. But it's likely that the product will be rolled back, and there will be so many issues or defects that we need to fix before we have a reliable product. So testing plays a very important role. As a tester, even though you might have a smaller role compared to other team members, it's a very critical role. Everything depends on you. On the one hand, we improve the quality of products as we repeat a test, find defects, fix cycle during development. Okay. On the other hand, we assess how good our system is when we perform system level tests before releasing a product. So at every stage, we do different types of testing. When I explain you different types of testing, I'll explain you in detail like what might occur if a particular type of testing doesn't happen on an application. Either it's new or either it's an enhancement of an existing project. Now there are different analysis that we do within quality assurance team. The common ones are static and dynamic analysis. So in static analysis, it's pretty much from looking at, or by visualizing, by having enough knowledge on the documents or the application, you can figure out whether whether there are defects in the application or not. So it can include a code review. You go through a code, and now developers there, when they develop the code, they're going to do a code review. When you look at the code, and if you're too technical enough to catch the bugs then and there, identifying that something might not work, it comes under static analysis. Anything that we inspect application and instantly we tell that something is not working. So if you look at an example, actually this is one of my friend's website portal. Now he developed this application here. Many of the features don't work here. As you see here, there are some images missing here. So by looking at it, you know that the website is not complete. This comes under static analysis, a simple visual observation. And there are different types again. Walkthrough. If you go through a document walkthrough and you go through the flow of the content, flow of the business, and then realize that the flows are not accurate. Like if, for example, you check out before you even submit your credit card, that's not a valid flow. So by realizing the flow, you can make out that this is not correct. Algorithm analysis. So you, in certain cases, in data related applications, there will be a lot of complex algorithms. Now your credit card score is generated based on a complex algorithm in the backend, and many companies use these algorithms. But can you read through all algorithm and make out whether it's performing in the right fashion or not? It's very difficult because it's too complex. There are many data that flows from one location to other location, and you really don't know what is the business meaning behind it. You have to have that knowledge. And in static analysis also, by examining code or by examining a code or by examining a document flow or a business in flow, you can easily make out that there is a issue or a defect in a particular application. What is dynamic analysis then? Dynamic analysis is actual execution of the program. Now the developer writes a program itself. A simple application yesterday I showed you to an HTML code. If I put all the tags there, I can open that in a web browser and see the content there. All I added is a simple line there. But when developers do the coding also, what they do is they will have to do unit testing. They will run the code on their machine and see whether it's working properly or not. For my site, okay, I'll take you example of QA training for job.com. Okay, this is my portal which I do. So if there is something that I need to fix, what I do, I have a backend dashboard and I constantly modify it. Now this is something I added. I go to the code actually content. Like I'm connecting to an FTP server, my web server where it's located somewhere hosted on a GoDaddy, server. Now I access the content there. And if I have to fix any code backend, I just copy the code onto my local desktop and test it right now. Instantly I can do that. It's that simple. And developers do the same thing. They use the code and run the code and make sure that application is performing fine or not. And that is comes under unit testing. But they can't see the entire application itself, but they can see a particular unit. So multiple units become a system. That is where actual system tester comes into picture. That is you. Now in dynamic analysis, when they run the code and the program, if it doesn't perform as it is expected, then there is a bug. So by running, by execution, you are figuring out that there is a bug there. So that is dynamic analysis. Anything that you spend more time and make sure all requirements are tested, that comes in dynamic analysis. I hope I'm clear so far. You have any questions? So these are the terminology that interviewers might be interested in. And if you are pursuing ISTQB certification, these are some things you need to learn and understand. Now there are different terminology for QA. Now we talked about assurance and quality. We talked about analysis. Now static analysis and dynamic analysis. Within QA, there are certain terms called verification and validation. Verification is exactly like static analysis. You are evaluating a software system by determining whether the product of given development phase satisfies the requirements established before the start of that phase. So that means that we have written the documents, and now by looking at this document, I don't see the application yet. All I see is the document with all the requirements in it. And if I realize that something is not possible to even test it, or even the requirement doesn't even make sense, that is called verification. It's similar to static analysis. Now validation will be similar to dynamic analysis. So if you put it in a definition way, you can have an intermediate product, and you can have requirement specification or a design specification, like a design and a flow chart or actual code itself, and you look at them and figure out whether there are any issues. That becomes part of the verification. Correctness of a development phase, if you put in simple, are all called verification activities. Validation, okay, coming back to the verification here, some of the examples I put here. Verification strategies comprise of this following: a requirements review, a design review, code walkthrough, and code inspections. I took 4 examples, but there might be more. Looking at the business flow and fixing the business flow itself comes under verification strategy. Now, under verification, a verification strategy, requirements review. What is a requirements review? The study and discussions of a computer system requirements to ensure they meet stated user needs and are feasible. So the requirements, we take the example of this one. Here, this company, they wanted to create paintings. Now they wanted to see that for creating new painting, every painting always belongs to one theme. For example, a modern art or nature. Is this possible? It's possible. So you can categorize the paintings and put all the paintings in one category by category. Any user who goes to the application can click on the category and browse through multiple paintings underneath the category. So it's possible. So that is a requirement review, whether it's feasible or not. What is design review? The study and discussion of computer system design to ensure it will support the system requirements. Now, the design for this application will be created, okay, and I don't have an example for this one, but if the system analyst, they come up with the design, the flow, like create application such a way that you create categories. I'm giving an example. To create a categories, underneath you create the products, then it's workable. So that is a design review. Now if you don't have an option in your code to add categories and subcategories, then it's challenging. Then by design review you figure out that this scenario might not be possible. Code walkthrough, informal analysis of program source code to find defects and verify coding techniques. So you look at code. Now I have the code here. This is a PHP code here. I have functions here and everything, and it uses model view controller kind of model to create an application. So this application is created in such a way. Now if I forget this syntax here and I try to execute this, obviously this particular file will not work because I forgot to end this line here. So by looking at it, you figure out there are syntax errors or something not defined properly. And if in this case I'm assigning a particular view and I forgot like $this. Okay, so developer forgot to code it, and you're reviewing the code and you figure out something doesn't look right there because it's not. In the PHP code you have to have a continuity, like you define an object and you need to specify which object it's coming from and what are the values that are you passing in a particular for that object. That is defined, and $this is very common there. So by looking at it I'll figure out, oh, this is not accurate. That is code walkthrough. Code inspection, formal analysis of program source code to find defects, which is running the code itself. Now I copy the same file onto my server where my application is loaded right now. What's going to happen? That video won't display. Now you won't be able to view the training videos because I have modified one particular syntax there. So that is code inspection. By verifying whether it performs functions as expected or not becomes a code inspection. Okay. When you go to interview, remember these, like what are different types of verification strategies. You can come up with these examples, and these are all related to static analysis again. Now what is validation? As I told you, the validation is much closer to the dynamic analysis. Now, activities of this kind help us in confirming that the product meets its intended use. Now, for validation, you are testing, you are writing test cases, you are executing them, you are making sure a business flow is followed. You are testing with different type of data. That becomes a validation. Now, validation activities aim at confirming that a product meets its customer expectations. So, our end goal is always customer expectations. What does the customer want? That is what we are creating here, and making sure the application is as designed. Okay, if on hotels.com, if you don't see a price there, or if you don't see any area, now if you don't have a star rating here, for example, I'm telling you this, so they have lots of features on this particular site, and I like this particular portal. Reason being, there is so much content in it. If you can break down, so many multiple pieces of code are mixed together to show you this portal. So here, if this portal doesn't have a star rating here, doesn't matter. You still, the core functionality will still function as it is, but star rating is missing, which is a nice feature. It's a nice to have feature. That means if you have a star rating there, the customers are more likely to use that feature to only shortlist only those particular hotels. And now in this case, I see only one 5-star rating hotel, and I always want 5-star rating. So I'm going to continue and book this hotel. So our validation is, is to make sure the core functionality is working fine, but not all the, you can test everything, you can validate everything, but it's based on the requirements, but those are not showstoppers. So even when you take a validation there and you find something is missing, still you need to raise it as a defect. My main point here is, even though you validate and you find the requirements are all met, but something feature which you think add values should be raised as a defect. That comes under part of validation itself again. Or if the performance is too slow to showing, when it shows the data back to you on the portal, if you don't get the results back quickly within seconds, then it's not good. I mean, it's a bad customer experience. So you're validating it and you put a defect there, but none of the requirement tell you whether to check how many seconds does it take to get you the results back. But your validation scenarios should include those also. Think in all directions. Think yourself as a tester when you create these scenarios. Now, validation strategies. There are different types of validation strategies. What are those? Unit testing. We just talked about unit testing. Unit testing is piece of code developed by developers do that. They test it. They can't just write on promote the code from dev environment. Dev is the development environment. I'm using short-term words here. Development environment also, but in real time you will call it as dev environment only. You don't say development in beginning. So experienced people, they just say dev, QA, UAT, performance, perf, or prod, like that. So from dev to QA, if the application is not good from the core functionality perspective, then it's not a what's going to happen. You will raise defects, and the code will be reverted back to the developer, and the developer will have to fix the code. So that comes under unit testing. So if he does the unit testing, make sure the core functionality is working fine. Then we can continue with our integration, system testing, end-to-end testing, all the different types of testing. Now, integration testing, you have two different applications. You have application, as I told you, a front GUI interacting with the database. Okay, and there are two applications here. I'm giving, if you look at simplicity, this is at least 10 years old concept. Two applications interacting and a transfer of data. Nowadays, we have applications so complex that there are multiple applications that interact and give you the end product. A GUI is sending information from one location to other location, and anything that is in the middle is called middleware. It can be any kind of data transfer which you don't know. Now, when you do integration testing, you do both together. You don't test only the GUI or you don't test the DB. On the GUI, if I look at the website for greenwaiver.com, okay, that portal example. Now, if I look at the application here, I'm seeing that some images are missing here. That becomes only GUI testing. But if I test more actual business content itself, whether the data is being stored in a database or not, that becomes an integration testing. So validation has, integration testing is also one piece of it. Now, what is system testing? You will have 4 to 5 applications interacting at the same time, or many applications interacting at the same time. That becomes system testing. So unit testing comes first. Next, integration testing comes. After that, system testing. Now, if you have 4 different applications, and I'm trying to recollect the picture which I've showed you. I think the technical design document. Let's go there. Okay. In this example here, this is a technical specification document. You have a workstation and they have defined clearly that data is transferring from workstation to web server. Web server is going to parse the information. Then there is a firewall to make sure only forward the right secured content. So this is a secured layer here. Then the data is transferred to WebSphere application server. Okay, that application server, it parses the data there and again sends that information back to the database. So there are multiple applications here and everything becomes a one big system itself. In that case, you have to test all these applications together. This becomes a system testing. You need to check data, you need to check scenarios, you need to check anything that really makes sense for your project to be successful. Performance testing. Performance testing, now in this case, if I send some data from my workstation to the web server and to the application server, now from hotels.com, you open a browser here, right here. Now, and that content is being transferred to a backend application, and you don't know how many layers are there. Can be 10 to 15, we don't know. So that when that data is being transferred through multiple channels, you need to get the response back. As you can see, the arrows are pointed both ways. That means data is sent in one direction, it's parsed, and data is sent back to the browser again. Browser will parse the data and show you the exact content, how it needs to show. Okay, so if you look at the portal here, okay, this portal can have HTML by default, as you can see, and it can have styles. Now, how do you get these colors? It's called CSS. They use CSS, and there is JavaScript also. How do you get different layers here? Different star ratings here. That is used by JavaScript. So there are lots of layers of code sitting on this portal, which you don't know what kind of code you are looking at there. So all this has to parse the information and give you the results instantaneously. Now I don't want 5 star, I need a 4 star. How many seconds did it take here? 2 or 3 seconds. So that is performance testing. You're performing by checking how much time it's going to take to receive a message and parse it and send it back. And what if all the users, and you are on a July 4th weekend and you want to book a hotel, everyone wants to go to the same hotel, or FIFA is happening right now. So if you go to Brazil, everyone wants to book hotel at the same time because there are thousands of people, and at a time they hit the portal, like many people want to book the hotel. What's going to happen? All these messages are parsed at the same time. The server has to still parse the data and send it to the browser at the same speed or much, might be a little more, but it should not take too long. It can take, instead of 2 or 3 seconds, it can take 4 or 5 seconds, but it should still give you the content as quickly as possible. That is done through performance testing. That's a valid scenario. Okay, and performance testing is how many number of users checking a particular application at the same time within a certain time, which is nothing but something like an X and Y axis. Load testing is only how many people are hitting the portal at the same time. That is load testing. You have 25 users hitting, 25 million users hitting the same site at the same time. That is load testing. But over a period of time, the same load has to keep hitting the server. That becomes performance testing. When I tell you about the actual definitions, we'll talk about them in detail. Alpha testing. Then you might ask, what is system testing? What is alpha testing? Alpha testing is you do on an application at a system level. Like you are an internal tester, you are testing it, you are internal to the company, you're testing all layers of this particular application here. That becomes system testing, and it's also alpha testing. If you let an external user or a business user or somebody who is in business who wants to check the data, and they are only running some queries on the database to pull the data and make sure they see the right information there, that becomes beta testing. But does it come under system testing? It's also system testing. It's a subset of system testing also here. User acceptance testing. So beta testing comes under user acceptance testing also. In some certain cases, a business user can test in QA environment. Yesterday I mentioned about different environments that are common in all organizations. Dev. So this understanding of environments is very critical, because the code moves from one location to other location all the time. Okay, you have dev, QA, you have UAT, you have performance, you have production at the end. You can have pre-prod or some other layers also, but to make things simple, let's suppose these are the 5 layers we have, and the code moves from dev to QA. Then again the code is tested here, or you find any issues back, then you move code back to dev environment. Then the developer fix the code again in a second run, you get the code back again, then it's perfectly tested now. Then the code moves from QA to UAT. UAT is user acceptance testing area. It's separate server, file server, separate content itself. It can point to different applications. So if you have a GUI application developed on Java and you have a backend Oracle database, okay, there are 2 applications now. In Dev you'll have the same 2 applications. In QA you'll have the same 2 applications. Every environment you'll have the same 2 applications only, but they might be different instance. That means this is on a different server. Server number 1, okay, Dev content. Server number 2, QA content. Server number 3, or server number 2 itself, you can have UAT also there. Server number 3 on and perf environment over there. And now this one is a critical one, which is a production server, where you have these 2 applications as well as many more applications together sitting on top. As you can see, QA and UAT can be on the same environment, or Dev and QA can be on the same environment. But if you have these environments separated, that makes the code more standard and make it more viable actually to succeed in a production kind of environment. If Dev, QA and UAT all are on the same server, imagine a server as your machine or your laptop or your desktop. That can be a server also. So in that server you have 3 different folders. One is Dev, one QA, one UAT, and you work on one folder. You move the document to another folder. Now you move the document to another folder. Okay, so you're making sure it's good in one folder. You're making like that. So similarly, if you have 3 or 5 different laptops here or desktops here, you work on one desktop and you move the code onto another desktop, which is much better QA environment, and you test it there. Everything looks good. Then you move the code into user acceptance environment, which is another desktop where only business can only access it. They will test it there. Everything looks good. Now you have a much more powerful new desktop which can test with any number of users. That becomes the performance environment. And the final big large new desktop with more features, more capacity, more powerful will be the prod. So you're moving in different places, you're checking at different places whether the application still performs the same or not. So that means the code is migrated when it is fixed. And all this validation again comes under QA environment, QA role only. But it comes under testing. It can be QA role, it can be, in some cases it can be business people, it can be developers itself. So unit testing developers do here. System testing, integration testing, we do it in QA environment. In UAT, business will do alpha beta testing or any business scenario testing. Performance, there might be performance team who does the performance testing. Finally, in prod, now we give it to the customers. They will start using the application. They were indirectly testing our application, but we don't want them to be our testers. The reason we want them to use, and if you want to make a customer, their customer experience is very critical for the business success. As a business, the business company has to succeed. They need to make more money. To that to happen, the customers should be satisfied. And if customers are only satisfied if they get all the content, all the expected functionality in an easy fashion. If it's too complicated, they will never come back. They'll go to some other location. Okay, you have antivirus applications, Norton, McAfee, Kaspersky. You go to use one particular antivirus application which is simple and easy to install. On my machine, I use Norton. I've been renewing it every yearly, and I upgrade the actual code, but practically it's easy for me. I'm paying, even I can pay for McAfee to buy another suite and install it on my machine, but I have to start again. But this is easy because it redefines all the virus and everything. So I'm happy with the product they are providing, and it's fixing all any bugs, and my performance never got affected. That way, I'm, as a customer of Norton, I'm happy and I'm continuing it. If Norton doesn't fix viruses properly or can't identify viruses on machine, obviously I won't stick with them. I'll go to someone else. So that's a business that they are not providing. But if I don't like, if this application is not even upgrading to the new version of software, obviously I'll go to something else. So if Norton's testers, they didn't test properly to send upgraded version onto my machine or any customer's machine, obviously I won't stick with them. That's a customer experience issue there. And other types of validation are installation testing, beta testing. Beta testing, we talked about it. Installation testing is where you, for antivirus itself, you get in the form of CD, or what you do, you install it on your machine, or you get Windows operating system itself, you install it on a new desktop. Okay, anything that is installation testing. So any software that is created and shipped out to the customer should be tested, and as a tester you will that will come under validation also, and you will have to run this and make sure. What if you do in a security testing or a network testing? You will test the switches also. Now Cisco and these, they have so many hardware components, they have routers and switches, and so much data is being transferred. If they build an application, build a switch or a hardware component which doesn't work properly, do you think they will have the customers? The customers will go for a better option. So that has to be tested as well. That will be a different type of testing. But does it come under validation? Yes, it will come under validation. There are many types of validation strategies. These are some of the examples. Any questions? Hiral, are you all already asleep? So all the definition are defined here. Okay, so that completes verification and validation. Before starting with the failure, error, and defect definitions, I'll take a break here for 5 minutes. Then we'll continue again. Hiral or Madhavi, any one of you has any questions? So you can type through chat. If you don't want to talk, that's fine. Hiral, you there? Okay, let's take a quick 5-minute break. Now the time on my machine is 7:05 p.m. We'll start back again at 7:10 to continue with other definitions. Okay, I'll be recording this video, so during the break I will stop the recording and we can continue again. And if you are not there, you can listen to the video content and ask me any questions later too. That's fine. Hiral, are you able to hear me? Let me unmute you. Are you able to hear me? Yeah. You need 5 more minutes? Okay, I can wait. Okay. Okay, let's continue with the class. Now let's talk about definitions of failure, error, fault, and defect. What is a failure? Now all this terminology look very similar, but there's a little difference between each different kind term. Now, what is a failure? A failure is said to occur whenever the external behavior of a system does not conform to that prescribed in the system specification. So doesn't it look like a defect? It looks similar to it, but is it same? Let's look at the defect meaning also. Now, error is a state of system. In absence of any corrective action by system, an error state could lead to a failure, which would not to be attributed to any event subsequent to the error. That means you are browsing internet and suddenly some website is down. You will get a 404 page which says that page cannot be displayed. That is an error state. So there is some server is down somewhere. You are unable to access that particular website because it's hosted on the server. That server went down. It's not up anymore. So that is the state of that system. Failure, it occurs when the external behavior of system does not conform. That means the application is working fine, but some content is not working as expected. That is a failure. Error is like total failure. Okay. And what is a fault then? A fault is edged cause of an error. So the fault can occur due to an error in the system. And then what is a defect then? Defect is again a combination of all these together. You have to realize the importance here. So when you try to go through the documentation, go through the requirements, create your scenarios and test it, you will find different levels of functionality that either pass or either it will fail. Why use a pass or fail? Because it can either be successful or unsuccessful. It can't be both. So either some piece, some sub application or subroutine works properly, or it totally fails. So defect can be a combination of everything. You will raise a defect if there is a failure, that is a partial error. You will raise an defect even if you have a complete failure, which is an erroneous system where something went down and you don't have access to that application anymore, or a fault. Fault can be also be a part of error, can be due to something else. Now the application is up, but the content that it needs to display, it's unable to access a particular folder to display all the content on the website. Then that is a fault. And now you still need to create a defect for it. Defect of an application, defect of a system, or defect of the quality, in the quality. That is what we are trying to find here. We want to we know that the application has to perform in a certain fashion, and if it doesn't do that, then it's a defect. Now if for performance even you don't get the response back from server in a timely fashion, it takes longer than expected, it is still a defect. It is a performance defect. You specify the defect, but it's still a defect. Now if the application has a capacity of 100 users only, and now you have 101 users accessing the application at the same time, and it will fail. That is a stress defect. Under stress it's failing. Okay, and if you have a database and you have Oracle and Java, that's the example I took there. So Oracle, now the latest version is I think 12G or something. Let's say we have 11G. Now we migrate from 11G, upgrade from 11G to 12G, but our Java application is not connected properly and some of the code is not working. That is also a defect. So anything that is not as expected becomes a defect. Can be a test case, can be a requirement, can be a use case, can be a flow chart, can be any type of document, can be a project plan, but we don't raise defects on a project plan. We only correct it because those are the verification scenarios. We look at and we identify, but we don't test anything like that. But from the document perspective, you find some content has to be updated. It has to go through a change control process. That means you are identifying a defect in the document. which has been not documented properly. So what happens in real world is all the teams will come together, talk about a project, and they discuss the actual business itself to see how feasible it is to make it successful. Now when we write the business requirement, that's how they discuss and they add the requirements. The business analyst will put some tentative requirements. That means they are draft version of the requirements, and some of them might be modified as they explain along. And some other business person might say the requirement is not testable, or it's not part of this project. Then he's going to have to remove the requirement. So in the final version, by the final version, you will have all the requirements readily available. That is the golden copy which you'll use for as documentation to create all your scenarios. You can't use a draft version of a requirement document to create your scenarios. You should always use the latest version of the document. So identifying the requirement bug, requirement is also a bug. You are raising against the requirement itself. If a business, as I showed you in the picture, business wanted something, they explained something else differently. As a tester, if you find this particular defect well in the beginning, it's like you're saving a lot of money. So the money spent on discussing the project, preparing the plan, writing the requirements, writing the design documentation, writing the code, then testing can be avoided, because you look when you enter the design or JAD sessions or joint application design sessions, you figure out that whatever the customer is expecting versus whatever is documented is totally different, and you escalate it then and there. The cost of fixing this defect will be very minimal. As a tester, we have to think beyond testing, not just testing an application, but we need to think from broad perspective. What value are you adding in a particular project? Okay, I hope you are clear with the definitions for all these three of them. Now I want to talk about regression testing. Regression testing, you might have heard about this. So regression is nothing but repeat again and again. Now regression testing can occur at different types of testing. It can occur at unit testing, it can occur integration, system, and acceptance. Now you build a product. Let's say we build, I'm going to use an HRM application in all my examples. So I don't know what's happening here. Okay, never mind. So if I develop an application and I'm using an example of Orange HRM, it's an HR management application, human resource management application. And that particular application, let's see if I can open it or not. I put it on a cloud, so yeah, the trial expired. Okay. Now, while testing the application, there are multiple versions of the same application. So in the initial version, when the application is created, there are some bugs. Now in unit testing, the developer did unit testing, he fixed the code, and he created the code, he moved the code from dev environment to QA environments. In QA environment, we do the integration testing, and we found some bugs. Then we move the code, we raise the defects. The developer will work on the same code again. Then he will push the new version of the code. So we started at 0, then started at 1, then the new version is 2, then new version 3. It will go on and on until you have a stable product. For that to happen, you don't know which version of code you might be testing by the end. You send the code to the production. But how many times do you need to retest again? You created scenarios for one time, but whenever there's a defect is fixed, you will test the defect, whether it's performing perfectly or not, but you need to test the other functionality as well to make sure if it's working or not. In hotels.com, if star rating doesn't work, developer fixes the code for the star rating, but I want to make sure all other content is displaying as expected. Okay, and also all other functionality is working as expected. So there will be some regression test cases that has to be rerun again, re-executed. That means you'll follow steps one by one. In manual testing, you follow steps one by one and try to test on the application directly as a tester. Regression testing is redoing all the scenarios again and again until you have a stable product. So regression testing can occur at any stage. Unit testing, it can occur in integration testing, it can occur in acceptance testing. In acceptance testing, we don't do regression testing. Reason, this will occur in UAT environment. By the time it goes to business users who are testing, user acceptance tester or business testers, the application should be stable. That means there shouldn't be any defects there. All those issues are all fixed and working as expected. And our business users will do regression testing only if the application is again come with a completely new version. Now there are major version, there are minor version. Major version, okay. So let me take use a notepad. So the major version, you have application versions is 1.0, 1.1, 1.2 like that. Our major version is 1. This is the major version. 1 is a major version. Any version after the dot becomes a minor version, and patches or anything, whatever you want to call. You have 1.0.0, 1.0.1, 1.0.1.2 like that. This becomes minor versions. Okay, so when we have these major versions, anything that needs to be retested, we do regression testing. What if a new version 2.0 come into picture? This is a new version of the application itself. Total revamp of the design, layout, can be functionality, can be anything. So the major version is different now. Does this become, do we do regression testing? We also do regression testing, but the business users will also do the regression testing in UAT environment or user acceptance environment. So the versions define whether you do regression testing or not. It will define how much of scenarios you need to test. You need to come with an optimal. Now you have thousands of test cases created for the application. Do you test each and every test case? No. You test only the optimal. What is an optimal number? There is not an hard written formula that you can calculate. Like if I have 5,000, I want to test only 50 of them. No, there is no defined rule. So you have to come up with scenarios which really make sense for that particular scenario. On hotels.com, if you have test case for all the different components in the application on the portal, and the developer fixed only the code for this, instead of stars, he put something else here. Your test cases should concentrate on this one, because that becomes a new feature or the minor version of the code. But in the major part, everything should work as expected. Your regression will be major steps. You still want to check a hotel, make sure the content is displayed properly, make sure the price is displayed, and whether all options are available or not. There are some rewards here, reviews, whether they're displaying. So you have to pick which one makes more sense. And there are certain terms called sanity test or smoke testing. So this will come as a sanity testing. Sanity means cleanliness. So your application should perform to a certain extent. So you will identify the test case to make sure that certain extent is met or not. That is the optimal number of test cases that you need to find for regression testing. And that is something that you will develop as you work on different projects, and by experience you will gain that knowledge. We are moving on to a new topic called quality assurance, quality control, and testing, and what are the differences between each one of them. As I've mentioned in this class, now week 1 and week 2, mostly it will be theoretical. So mostly it will be definitions, it will be models or flows of different process that we follow. From week 3 we'll have practical version where you will write test case also in quality center. I'll make you write a test plan, make you write high level scenarios, and there will be a homework to create test plan as I've shown you, and also you'll have to write some test cases high-level scenarios, test cases, then put it on quality center as well in the class. I'll let you do it. I'll share my screen and I'll let you do it practically. We'll touch Selenium at a basic level. I don't want to go into depth. That will be covered by a different class. Now, coming to the example of quality assurance, quality control, and testing. Quality assurance is you are assuring your partners that this particular application has met certain criteria to perform at a certain level. You do many activities and you're ensuring development, you're ensuring your end users that this is 100% quality assurance on this particular product. It's assuring the product. Quality control is while performing quality assurance, while performing testing and doing all this content, you need to make sure you have done the right job and you need to measure it. Every activity has to be measured. If you don't measure an activity, for example, you want to measure the performance of an application returning the content. Okay, so that is a measurement you're getting in terms of numbers, like how many seconds did it take to get the response back, how much, anything with the number or the metrics that has to be measured, and through quality control we do that. Now you create, as I told you, we start with five different phases. If I put it simpler: planning, analysis, design, implementation, and maintenance. Now in planning, if you find a defect, it is cheaper, and that is, by verification and static analysis, you are figuring out how to find a defect well in advance with your knowledge. In design or analysis or design, you still you find bugs in the documents, or or any flow diagram that is not properly represented. That saves a lot of money because the developer hasn't coded yet. Anything that we involve developer costs more because he has to work on the code and migrate the code, and there might be some other team which does the migration. Migration means taking code from one folder. As I told you, you have these 5 different folders in the same system. That system might be the company, and the 5 different folders are different servers. For example, moving from one folder to another folder, somebody has to do it. So that takes time. That takes time. When time is consumed, money is spent. So you are spending their money to make sure that it is fixed. So before even the coding is done, before even the documents are all created, we find issues well in advance. That saves a lot of money. So finding a defect at early stage is cheaper. If you find any defect in testing, is costly, and the most costly is if you find a defect in production. So because you will have customers looking at the site, looking at the content, working on it, then they find the defects. That is very costly. That will cost you in humongous way which you can't even express. You will lose customers. When you lose customers, okay, take the example of healthcare.gov, Obamacare. People wanted to buy healthcare insurance on the same day. The portal crashed. There was so much bad news floating around about the portal just because of the portal, not about the kind of health plans they are providing, because it is unavailable most of the time, because they didn't do performance testing as expected, and they didn't anticipate so many people to hit the server at the same time. So cost of fixing that portal is very costly because you already put the portal on the production. Everyone is looking at it. Millions of people are looking at it because everyone wants to buy an health insurance plan. Similarly, a company's customers, when they try to access the content or service or software or anything, it has to be 100% quality. If it doesn't, then we have failed as a tester. Our failure, it should not happen. I haven't seen so far. In some cases, there might be requirement that you can't test. Okay. Now, for example, usernames and password that you use on Yahoo Mail or Gmail. So there might be a requirement which says use a particular type of encryption on the passwords. How do you test it? It's very challenging because the encryption is to make sure that nobody else look at the passwords, but you want to decrypt it back You put it in code and you want to put it back into the actual layman in a word like a simple alphanumeric characters, doesn't make sense because there is security involved there. In production, you can't do it. That means you can't go into a customer's account and do all this kind of activity over there. So those are non-testable requirements. You can't test all the requirements, but whatever requirements you test, they should be they should have utmost quality and they should have the assurance. Now, by control is to make sure how much money you have invested in fixing a defect. Like if you fix a defect in development in QA environment, who are the people involved there? You involve analyst, you involve developer, you involve QA by default. You will have a project manager who will talk about the defect, and you might have any other database team or migration team. So you are taking their time to make sure that defect is moved along. There might be many. So when you calculate, take a cumulative figure of the cost, it might be a large number. So you invest $100,000 on a project. For fixing the defects, you spend another $30,000 or $40,000. That means our job as a tester was really bad. But if you spend like $100,000 and $10,000 to fix the defects, which is pretty good, because there might be some defects which we will definitely find after it has passed the QA environment also. But I hope it doesn't happen, but it's a possibility. So that means we did a pretty good job. If you don't find any defects in any other environment other than the QA, that means it's an awesome job. And we found all the defects that we could find in an application, giving it 100% quality. Now testing is, now we talked about quality assurance. We are saying the quality of a product. Now testing is to test the system itself. We are testing by either straight validation, through system testing, level of testing, or performance testing, or stress testing. Now we are not talking about quality here. We are testing the application, testing the module, testing login that flow, or testing a particular use case flow. So you are trying to recreate the scenario just as it might happen in a real time case, and making sure it is working as expected. That is testing. Here we are not talking about quality. Once testing is completed, then we talk about quality. Software quality comes into picture when testing is 100% done, and when it is when we assure that everything is good and all the testing has been completed, that's when quality assurance will come into picture. That's when we'll say how much of assurance we can give on this particular product by quality. And quality assurance is not only limited to software industry. There are cars manufacturing companies, they have their own quality assurance teams, they have quality control teams. Pharmacy industry, there are many industries which use quality as their main feature, and without that no company can succeed. And it's not just a new terminology, it has been from old age, it's been there. Quality check has always been there. Okay, and to put testing in a simple layman's terms, it's nothing but finding defects by executing a system or software. Okay, now what are the roles and responsibilities of a QA analyst or tester? Now QA tester will follow a documented test plan and be responsible for reporting a clear and very detailed bug reports. Everything has to be detailedly written. Test plan, test cases, scenarios, test data, everything has to be created and done. The QA tester will work with their fellow testers and senior tester to ensure quality testing and bug reporting is maintained. Okay, if you join a project, what should you expect? You are part of a team, or you are an individual contributor. You have to start from there, and your job is not to only to test. Your job is to work as an analyst, analyze the business. If you understand, once you join the project, you understand the business. The first step I would do is try to understand the business. If I don't understand the business, I can't test any application within the company. So by working in a financial company, if I don't know how the trades are created, how they are successful, how we get messages back from the brokers, then I can't test any application, like, I mean, without that knowledge, or what kind of customers we might have in a financial company, what will be their, where can I look for the amount or how much they are investing. All these details I need to know as a tester. If you are in healthcare, you need to have different type of knowledge, but we need to think as if you are an analyst. Then only you understand the business, then you elaborate it, try to redefine the business through your test cases, and test the system itself or application itself. And you also need to analyze user requirements. You have to understand and document all the procedures. There might be multiple procedures that might be written to follow step by step. Are they accurate? Anything is testable. Literally anything is testable. It's up to you how you will define yourself. And you have to create test plans. And the test plan or test strategy, there are two different type of document that we use commonly: test plan and test strategy. Test plan is a simple document for a project which gives you information about what we are going to test, what is in scope, what is out of scope, what are our assumptions, who are all involved, how much time do I need to take from a testing standpoint, and testing life cycle, and where are these results stored. All that information will be there. Test strategy is a little different. If you have four different types of testing, you have a system testing, integration, you have performance, stress, and all different types of testing, and you're doing it on different servers, and you come up with all the different teams, how you're going to do that, it's stored in the test strategy document. So you have a strategy on how to address the testing of that application. So that document is a little different. And test strategy is generally created by the test leads or test manager. Testers will create test plans. And for any test case to execute, you need test data. That means you need to use a particular login, or you need to, if you are checking the payment process, for example, the payment processing processor has changed, then the credit card numbers test. I mean, you need to test that whether the scenario passes or fails with while you try with a particular credit card number. So that becomes your test data. Any set of data that you use for a scenario is a test data, and based on the test data, you can have the multiple scenarios. You can have one scenario, and it's generic, but you can create one or more test cases from a scenario with different type of test data. One test case for the same scenario will have one type of data. Another test case for the same scenario will have different type of data. So if there are three testers, we will use three different logins, but we are testing only one piece of code, login functionality, but we are using three different test data there. And we need to document and re-verify all the defects, and we need to document test results also. Whether it's pass or fail, we still need to take a picture. Like if you can take a snapshot of your success of scenario, or in the case of failure, you should take a snapshot definitely and put it in Quality Center or any other tool where you can document them and show it to your developer. The developer might not recreate it, or he might not find the defect while he does the testing. So it's always good to take a snapshot. So from my experience, when I joined as a tester initially, I used to take pictures whether it's pass or fail scenario. Nowadays, I am not doing that. I'm only taking only snapshots when a particular scenario has failed. But is there a risk there? Yes, there is a risk there, obviously. And if somebody come back and ask me that, show me all your documentation whether a test case has passed or not, and show me in snapshots of that success, I won't be able to show that. But it's always good to store the results, whether it's successful or a failure. Okay, so these are all there are different types of roles, and it might vary from company to company, might vary from domain to domain, and it can vary from model to model. Like methodology, SDLC model, if you're in a waterfall, your role might be simpler. If you're in agile, they might expect you to do multiple roles at the same time. They might expect you to test, document, create any plan or anything like that. So it depends. It's not always the same, but these are the common ones. Now coming to the topic of life cycle testing. What is a life cycle testing? You heard about software development life cycle, which is from one different types of phases from one end to another end. Okay, there is a software testing life cycle also. So that is again one end to another end within the testing area. Now life cycle testing is a little different. Life cycle testing provides testing capability across functional, non-functional, and test automation services for organizations across industries. If you put it simpler, so that means you started. If I now give you the best example, what do we do first? Let me draw here, that might make more sense. So first we start here, we create requirements, then we write, create other design documents, TDD or TSD, technical specification documents. Here business rules, BR, business use case, or also called as BUC, business use case documents, or any functional or business specification documents like BSD. So these are different types of terminology that we use, commonly use. Before this, there will be a project plan. I'm using abbreviations here. So, project plan and any other planning related documentation. Okay. So once we have TSD, then we create our test plan, test cases, then we create our defects, and defect is also document. So then we send it to production. So there are so many artifacts that we create along the way. Okay, so when you I lost it. So but when you test it, you test it in implementation phase. When the code comes into QA environment, that's when you start testing. That occurs in implementation phase. In implementation phase, while the code is received by developers, they start working on the code, and when the documentation is done, the developers will start coding in implementation phase. At the same time, we create our test plan parallelly. That occurs parallelly. Once they are done with their code, the code is migrated into QA environment. That's when we are done with our test plan. Then we start writing test cases and execute test cases, because the code is available now. Now our testing is started in implementation. So our testing life cycle is in that area only. We are not starting at the requirement phase, but if we are involved in the JAT sessions or application design sessions well beyond in the requirements phase itself, then your testing lifecycle starts there. You're trying to get involved from the beginning. But nowadays, with agile environment coming into picture a lot, you are only involved after the code is, or the design documentation is done, just before the code is complete, because of the time, and you want to deliver all the code or the product as quickly as possible. So the timelines have reduced. So life cycle testing, we are providing the capability, either functional or non-functional. That means the code, whether it's performing functionally or non-functionally, which are usability or it can be anything, and test automation. That everything comes under the life cycle testing. So from one end to another end, everything comes under the life cycle testing. It involves multiple applications. It involves all either databases or everything all in together. It also meets compliance and regulatory requirements also. So everything together, all testing together in a package becomes a life cycle testing from start to end. So that includes static analysis, that includes dynamic analysis, verification, validation. All this will come under the life cycle testing. When you do independent testing, or these are the examples. I'm sorry, I might be going a little fast here, but examples of lifecycle testing service are examples here. System integration testing, okay, performance testing, security testing, ERP testing, infrastructure testing. Infrastructure means environment, whether you have the right servers, databases, whether you have the right ability to code a particular, use a particular technology to code. Everything will come under infrastructure. Certification services, usability testing, user acceptance. So there are multiple levels of testing that we do, and all come under lifecycle testing services. Hiral or Madhavi, do you have any questions so far? Are you good? Okay. So moving on to now, life cycle testing involves everything. Now, what is the opposite of it? It will be independent testing, which is only at a particular application level. So if I take the example of only one component or one web page on a particular application, that becomes independent testing. Or I talked about the ratings on a particular portal, that becomes independent testing. I'm only testing that component itself. I'm not testing from all different types of testing there. All I'm making sure is whether it's functionally available for me to rate a particular hotel or not. That becomes independent testing, opposite of it. I forgot to include that in the slide here, but I'll try to update it and send you the detail. Now about the cost of quality, if you look at this particular picture here, it gives you enough information. Let me make it a little bigger. See, the cost can be created by multiple layers, either internal failure cost. Internal failure cost can be redesign, downtime of an application, retesting, shortages, delays, rework, lack of flexibility. So internal failure that occurs within the company itself or within the QA department itself, and or can be an application side also. What are external failure costs? Environmental costs, sales reductions, warranties, repairing goods, complaints. Now you don't develop all the software that you know in your company. You work in a particular domain, healthcare or finance or anything. They don't have all the products readily available. They have to buy from some other software vendors. If I use a ETL tool like Informatica or any other ab initio or any other tool, that means I'm buying the license of the tool. And if that application fails, my data is not transformed. So if I put it simplistically, we buy operating system software right from Windows, and you as a customer, you try to install Windows 8 for example on your machine, and the CD, that particular CD doesn't work properly because it's malfunctioning. So and you report back to Microsoft and they have to fix it and send it back to you. Who is going to pay for shipping cost? They'll have to pay it for, obviously, because it's a faulty product. So that is an external failure cost. Either you as a vendor or somebody as a vendor, cost can increase due to any number of reasons. Can be multiple causes there. Appraisal cost, like if you have a product, you are purchasing some other vendor software, and that vendor can increase their cost. You purchase software from HP for quality center or QTP, they can increase their license, that cost can increase. So when the cost increase, obviously your quality cost is also increased. Now prevention costs are that we do for for regression or anything like capability evaluations or error proofing, that you might create some automation test cases to make sure the application is still running and it's good. That means you're investing some time that involves dollars. So cost quality increase there. Quality improvement projects, quality education and training. You have to train people to make them upgrade them with the technology and features. That is another kind of cost. So this is an example of what different types of costs that can occur, and that can increase the quality cost on an overall in a big picture. So this is another example of how the quality cost is maintained. If you want high quality, okay, if you want high quality, as the quality increases from here to here and the cost is increasing from from here to here. If you want more quality, that means you need to do more testing. That involves more number of hours that need to be spent. Obviously, the cost will balloon up. So the cost is high here at this stage. If you want low quality, that means low cost. You test only few scenarios. So, but will the product succeed? It won't, because you haven't tested all the scenarios. Now, which is the correct optimal? So, if by this is an particular graph that I got from one of the quality assurance sites, and it's on our portal also. So, the optimal quality cost is somewhere here. It shouldn't be too high, it shouldn't be too low. So, if you have low quality, what's going to happen is your chances of failure of product is very high, and obviously the what do you call your upfront investment or investment that you need to do to redesign the product itself will be very high, so it doesn't make sense. And if you invest too much cost itself, sorry, if you write too many test cases itself to just make sure your quality is tested thoroughly, that increases the cost. But if you create optimal number of test cases to identify all the defects, like for a sanity testing perspective, you figure out you have 1,000 test cases or 10,000 test cases, you picture 100 of them become the regression suite, and you need to rerun again and again to make sure the quality of the application is maintained. That becomes your optimal. So the optimal can be something in the middle here, like the cost is not too high, the quality is also maintained at the same time. You are not giving full quality because you are testing only a subset of the test cases, but quality is maintained still because majority of the functionality is working. There might be some issues or defects, minor defects here and there, which can be fixed, or cosmetic defects where some of the images might not be working properly, or some content might be missing. That can be fixed much easily. So you have to come up with an optimal scenario. That my main intention here is to explain that you have to come up with optimal number of test cases while you do the testing on a project. Okay, let's take a 5-minute break here. I'll have some water and we'll come back in 5 minutes. In the meantime, think about any questions on the topics that we have covered so far. So can I continue with the class? I'll wait for a couple of minutes before I start again. Okay. Continuing with it, let me know if you have any questions, or let's otherwise move on to the next topic. The next topic is QA process activities. What are the different QA activities that we do in a certain scenario? Now, software product development. So in this particular scenario, a software product release is preceded by an internal QA cycle wherein test engineers from the product development group verify the product functionality against the feature specifications gathered from market sources or sales partners. This is followed by beta testing. So you are developing a product, and that product is tested by the internal QA before it is beta tested. This is in a product development example, where a product is designed. You can take an example of Oracle or IBM, or these all big companies, they develop different products. So they have their own internal QA who tests the products itself. Now, software application development or software servicing, here we are developing applications, and in this case, there are 3 levels of testing that may be carried out. The party involved in software servicing or application development carries out the first level of testing at the end of development phase, which is unit testing. At this level, the developed applications functionality is verified strictly against client specific requirements. So at unit testing won't be detailed, it will be very high level. Now, and it's followed by system integration testing by the testers, and that is done in QA environment where we test more number of requirements, and both the goal is to make sure all the requirements are thoroughly tested, but with different combinations. And it's also tested by the beta testers once it moves into UAT testing phase. So the examples which we used in all the scenarios today in our presentation are a combination of software application development scenarios. Product development is little difficult, or I don't say it's difficult, it's little different. You develop a product, and when you test it, you need to have that product ready. Application is something you develop on your environment and it's available. Product has to be created in your test environments to function as if it's at the client's place. So you design a software and you're sending it to other vendors. That means that software has to be thoroughly tested just how the vendor would perform on their side. And there are other types of software testing services. This is a category of software services in which the development partner outsources the complete testing of its product, application, or service to a third party. So there won't be any internal team that will be testing the application or the product, but there will be external completely. It's outsourced, or it's maybe beta tested also. So these are different types, but there might be many more. Now you might have heard about testing, and you want to become a quality assurance analyst, and many people talked about automation, performance, stress, and the common word which we use is manual testing. Now what is manual testing? Anything that we write in simple language and try to recreate a particular scenario becomes a manual testing. A person doing it just like as if he is told to do certain set of actions, that is manual testing. And you write your test cases in a step. There are test steps in a test case, can be one or more. So when you write your test steps, you follow step by step. Step 1 occurs first, step 2 occurs later, like that in a sequential order. So manual testing is to follow all steps in the same order and make sure your test case is tested. And most of the companies, even today, with all the different types of models and advanced technology, and with the cloud or software as a service or platform as a service kind of combinations, still most of them do manual testing. Automation is also being done, but it's at a certain percentage. 75% it's manual testing, 25% it's automation testing, which is good for us, because if you want to do automation testing, you need to know a particular language, a particular software language to create your automation scenarios. For QTP, you use VB script. For Selenium, you can use through Java, Ruby, PHP, or any other language, Python, to test on using Selenium as automated tool. If you use, I think these are the common ones which are automation tools that we use. Even for load runner, I think we use Java or VB script, I think one of them. But as a manual tester, it's pretty easy job. All we need to know is anybody who has common sense can become a manual tester. You need to understand the business, try to recreate the scenarios, then retest it in a sequential order, and that is manual testing. What is a QA cycle? When you join a project, you will hear these terms very commonly. They talk about QA cycle, they talk about life cycle testing. So QA cycle it consists of 3 different stages, and it's also called as testing life cycle. And certain in some environments they say it's a software testing life cycle, or STLC, or QA cycle, or testing life cycle, any of them. Now, with all the agile environments, but with people doing multiple roles, this is a little challenging. Okay, when you start development, when you start coding, the same person can develop, and the same person might even do a system testing also. In agile, that's how they are focusing, to make as fast as possible, deliver products as fast as possible, with at least moderate level of quality. Waterfall is good because you give with most quality, but it takes too long. You will have 6 months to 1 year projects, which goes on and on and on. Now, the first step in a QA cycle stage is test case generation. The stage starts quite early in SDLC, just after design phase. After the feature requirements are frozen. Frozen means once the requirement documents are updated and you say that is a final version, that means it's frozen. Nobody can modify it anymore. If anybody has to modify, they need to submit a change request. It's called change management. Okay, anything that goes on an updates on an approved document or an artifact or the code, it has to go to the change management cycle. That means you raise a change ticket to modify a certain artifact, as I told you, code or anything that is relevant. So frozen is something as a final version document. So once all the documents are finalized, that's when you start writing test cases. But in certain scenarios, you will write test cases before they are 100% complete. What might happen? You will test scenarios, you will find defects because you might have used draft version of the document, but that requirement might not be, the document might not be valid, and it might have been modified, but you have written test case for that and find the defect. Now developer has to invest some time to understand what is the issue, why it has occurred, and finally we realize that you have used the wrong document. It involves money again. So you need to be careful. Your test case should be valid all the time. Valid means if you are using the right requirement, document, right artifacts, that becomes valid, and right scenario. You don't want to test some scenario which is really not, which doesn't even make sense. For example, you want to test a login password scenario. In the password, you want to put some just only numeric characters. Numeric characters can be negative, but can be any junk characters, just to test whether it's taking the password. That doesn't make sense. It's not relevant to your functionality test there. So once the documents are ready, you create the test cases, and that is all comes under test case generation process. It's a long process when you need to create. I generally create high level scenarios or test scenarios. From scenario is a simple statement. From scenario, I will develop multiple test cases, one or more, using different data. Because if I start writing test cases, I will lose my direction. If I directly write the test case step by step, that will not make me focus on and bigger picture on the entire concept of business. There we are checking the functionality, and in order to check the functionality, you need to test in different combinations with the different test data. The moment you do test case, you will miss one of the scenario there. So in order to avoid that, create a high level scenario, then create test case underneath with different test data. Okay, the maturity of test case is a long drawn process, because you create test case a draft version, then you constantly update it based on the data that is available to you. By the time the code is about to be generated or migrated to QA, your test case should already be written and ready for review with all the stakeholders, and they have to be reviewed and they have to be corrected, and again the final version of test case have to be put back in a test management tool like a quality center or rational test manager. There are other examples. For requirement they use rational requisite pro, in some cases quality center also. So these tools are commonly used to store all the content, so whenever you want to access them, they are all at one big place. The quality center I will show you when we do some practical version, but it's a simple application which has modules in it, and it's pretty straightforward. Now test cycle planning. Now this involves also, before test case, actual planning has to occur. Planning has to occur because you need to understand when the code is being delivered, how many testers you need, when do you need to start executing the test cases, when you have to review the test plan, when you have to review the test case, all have to be planned for. So first planning will occur, then test and analysis will occur, then test execution will occur, design and execution. So there are like 3 or 4 phases within the software test lifecycle: planning, test case planning, test analysis, test design, and test execution. Okay, test execution is where once you have the code ready, at least a first version of the code, you will start testing. That is test execution. You can have multiple runs. Multiple runs means retesting. You find defects. Okay, there will be weekly cycles. That means in a week you execute some test cases one by one, and you find defects. Then you will give the assign defects back to the developer. The developer will fix the code. He should not move the code or migrate the code every day to QA environment. He will only send it on Friday to Friday. So once on Friday he will migrate the new code, then you retest again in the following week, like that. That is a weekly test cycle that you get code constantly. And when you execute, your version of the code is very important. And if you try to recreate a defect again, you need to identify which version of the code you have found. And also the code, if you want, once the code is stable and the application is stable, the code has to be promoted to production. What if they move the wrong version of the code into production? That is an error by, it's an erroneous scenario where we don't want to commit, because we want to send the latest version of the code into production. Whenever the code is promoted to QA, they will keep different versions of code. They won't write or copy on top of other copy. Every day it will be different. So, but while migrating from final UAT into production, you need to make sure you have the latest version of the code. And execution also is very important, that you need to make sure you have the latest version. Otherwise, from a tester's perspective, you can't know whether it's the right version or not. You need to make sure, you need to have communication with your developers, understand, and then proceed with your testing. And they can give you all the technical information in case you have any questions. So that concludes the QA cycle, and um, I've talked about test analysis also, which is related to pretty much analysis and test analysis and design is pretty much the same, where you analyze all the documents, go through what needs to be tested, what needs to be created, not only just the test document, but if you want to create any flowcharts for your testing purpose, you need to do that. Generate test data. In one project which I worked for one of the healthcare company, I had a situation where they have a new project, and the data they want to test is they want to provide certain services for certain type of customers. So they have like multiple types of customers, and they want to give each set of customers a set of products. How do I test it? So I came up with different combinations. I put everything in a, first I understood what type of scenario they want. I put it in a test, an Excel spreadsheet, and gave a correct direction. When I put it in Excel spreadsheet, it's easy. Now customer 1 will have these products. Customer 2 will have product 2, product 3, product 4. Customer 3 will have product 1, product 2, product 4, like that. So which then I know, now I know how to create a test case. My test data will include customer 1, and it has to check for the appropriate products. If I use some other products for that customer, which is not relevant, then your test case is invalid. So that analysis and design has to be done, and make sure that you don't have invalid test cases. And when you best way is to understand is, if you understand the data, everything is possible. If you understand the business, and if you understand what type of scenarios you want based on the data that you will use in the scenario, then everything should be good. So that concludes today's session, but I actually completed a little early in a couple of hours because it's all theoretical. Now, coming to questions, do you have any questions so far? This is an high-level overview of quality assurance and testing in particular. When you work as a QA analyst or a test or QA lead, or any automation tester or performance tester, what would be your role or responsibilities within your team? So this gives you an overview picture. In the next session next week, I'm actually planning to schedule weekday sessions from 9 to 11. I will cover week 3's content, which will have SDLC models and methodologies, and that will be covered, and we'll have 2 2 hour class 9 to 11 every day starting tomorrow. So Hiral or Madhavi, if you have any questions, you can either chat and let me know. I will try to answer those questions. Yeah, Hiral, let me unmute you. Yeah, Hiral, go ahead.
Hi, Varun. Can we do like weekdays timings like 8 to 9 or 7 to 8, 7 to 10? Because 9 to 11 is too late for us.
Yeah, that's the only time available for me. I'm trying to see the best possible, but sometimes I
About
come late in
7
the.
to 7 to 9.
Can we do like 8 to 10? Does it make sense? Couple of hours.
Okay, because I was thinking 7 to 9 is the best, like,
Yeah, I understand, but at the same time, I don't want to promise something which I can't commit. So if
Right.
I just want to make myself available. Sometimes I might have work from office, so most likely I'll wind up by 8 o'clock,
Mm-hmm.
and then I can spend some time. 8 to 10 works for me. Think about it and let me know. Otherwise, we'll do weekend only.
Okay. Okay, then I'll let you know.
Okay, thanks. And do you have any other questions in the topic so far covered? I'm going little fast because
Uh-huh.
most of it is theoretical here. When you do
Mm-hmm.
practical, you will really understand, and you know definitely you can stop me with any questions. This is all manual testing. It's pretty straightforward. So coming to today's quiz, if you don't have questions, I'll go to the quiz today.
Okay.
Can I?
Yeah.
Okay. So today's quiz. Now, test planning is done in which phase? In STLC and SDLC, which phase do we do test planning? We have planning, analysis, design, implementation, then maintenance. Which phase do we do test planning? When do we start writing the test plan? When do you think we'll have enough information? In analysis, we'll have all the business requirement documents, all the high level business rules or business use case documents. In design phase, we'll have system requirement documents or the system requirement specifications or any flow charts, all the wireframes. In implementation, that's when we start writing our test plan. During implementation or construction phase, you will have enough documentation, final version of documentation. That's when you start writing test plan. Okay. So the question here is from an STLC perspective. From STLC perspective, test planning is done in test planning phase, in test software test lifecycle. From STLC, it's in implementation phase. Hope I'm clear here. Okay. Our testing also has a life cycle. Second question, which document has information on life cycle testing? Hiral or Madhavi, can anybody answer this question? Which document has information on life cycle testing? All of them. All the documents we use from when we test from end to end, which include different types of testing, that means we need to go through all the documents. There is not one document that has all the information. You will have to go through all the documents. Third question, analyzing requirements is a part of QA role. True or false? Can anybody answer this question? Analyzing requirements is a part of QA role. Yeah, Madhavi, you can type, or if you want, I can unmute you. Yes, it's also part of QA role. You can type the answers here if you don't want, answer to the phone. What is regression testing? Can anybody, write the answer for the definition of regression testing? Regression testing is redoing again and again the same main functionality, or the core functionality has to be repeated again and again from the beginning. That is regression testing. What is error? What is the error? How do you define an error? An error is a state of a system or an application. Errors occur because application is either down or it failed or due to some other reason, some other breakdown. So it's a state of your application or the system. That is an error. Okay. So you guys have any more questions do you want me to repeat any certain content within the document today that I covered today? Which part do you want me to repeat, Hiral? Page, oh, error. Okay, let's go back to the content here. So there are 4 different types of scenarios that are possible. Failure, what we said is a failure. A failure is said to occur whenever the external behavior of system does not conform, because it's a partial error. a partial functionality that is not functioning is a failure, not the entire system breakdown. Error is a state of system where the entire application of system is not available for us to do anything. That is error. Fault is just like a defect, which is a subset of error caused by error. If the application breaks down, there is a network fault, or it's more closer to error. Defect is can be anything. It's a combination of any of the scenarios here. It can be combination of any other functional also. So it can be a failure, like a certain if I put it in the best way, if certain functionality is not performing correctly. Now what kind of error, what kind of scenario is that based on the definitions here? It is a failure because it's a partial error, and you raise a defect for that failure. You say that it's defective. Functionality is defective. The moment we say that's defective, we need to fix it, right? So that's a partial failure of a particular function of an application. That is a failure. So going back to other topics, if you want, I can go through some of the content just quickly. So we know verification validation. I think you understood. Regression testing, we know that it can be covered in unit, integration, system testing, and it can be in different environments. And it's done only in acceptance testing in the major releases. Regression testing. We understood the difference between quality assurance, control, and testing. And what are the differences? How do you measure? Through quality control we measure. And we know what are the roles and responsibilities of a QA analyst and a tester, what we need to do when we start on a project, how we need to proceed along. And testing life cycle involves multiple types of testing. So the documents that are needed to test a life cycle testing will be everything. Independent testing will be only either a one SRD, a system requirement document, or a FRD, a functional requirement document. Will be pretty straightforward. For life cycle testing, you need all the documents. What are the different phases in a test life cycle? You have test planning, test analysis, test design, test execution. Okay. What are the different types of QA process activities we do in a different type of model in a company? For product development, internal QA only tested. For an application, software application development or a software services, internal will be done, and it will be in 3 different stages: in unit, in integration, and system. If it's software testing services itself, we are outsourcing all the testing to somebody else. We are developing, but somebody else is testing that for us. Now, cost of quality, if you want to catch all the defects, the cost is very high. If you want to have high quality, the defect is also very high. So you need to only run the optimal number of test cases to find most of the defects with a low cost. So that is this level here. Okay. Now we talked about manual testing and automation testing and different phases within QA cycle. So far these are the content that we have covered, and I'll go through one particular document here called QA process management. This is created by Wipro and one of the, I think, employee over there, and I find this document very interesting article. So I'll share this document to you, go through it. Now she has put some interesting comments there, and she talks about different phases and what they did in particular, how they do it. Okay, go through the content here and go through each phase, like what involves in each phase. Now there are some of the challenges that she has put for each category. One is team collaboration, information assets management. That is nothing but different types of templates that you need to create documents. Category 3, she says scheduling and executing and tracking of test plans. Go through this document. It's very interesting. and this is how the test case are generated. She put a cycle and a flow of like how what happens in order. Okay, test cycle execution also, and finally how she used a certain example of her project while doing it. So that's all I had for today. If you have any questions, we can discuss about it. Otherwise, we can call it a day. I will meet you again tomorrow at 8 o'clock. 8 to 10 will be the class, and I'll send you the training invite tonight. And once this video is converted, I'll put it on the website, on the portal. I hope everyone is able to access the training videos portal here. Let me unmute you both. Madhavi and Hiral, I just unmuted you both. I hope both of you have access to the training videos here. So under video tutorials, I have added you as subscribers. So you should have training videos here.
Okay.
So this is a demo.
For day 1 and day 2, right?
Yeah. Day 2, I have to convert now. Once we end the meeting, it will convert the video, and I'll compress it and I'll put it on the site here. So on training videos is the content which you need to look in. And here you will have multiple videos here.
Okay, how about the supportive material which you showed me before, like Wipro and all those things? So you are going to share those documents, or?
Yes, let me do it right now. So I got 2 different emails from you, so I don't know which one I need to give you share. Is it
2014 is the latest one.
Okay. So you should be able to view the content in that folder.
Okay.
Thank you. Now coming back to the, you will have more videos here as we add for each day. Then in tomorrow's topic, let me see the curriculum here in a minute. So tomorrow I'll cover models and methodologies, and there are lots of models that I need to cover. I think this will take at least 2 to 3 classes. Then we'll go into different types of testing and testing methodologies. That will complete week 2. Then I think by end of this week we can complete the week 2 part. Then we'll move on to testing life cycle and test planning, actual practical approach. So come up with any questions if you have, and I'll try to answer. If even I can't answer it, I'll try to respond as soon as possible through email. Okay.
Okay.
Thank you. Have a good night.
You too.